let's dive into the projects that we have. I will share some slides.
Okay, so hi everyone. So I'm Ruth Sofia. I lead the Codeco project, which is one of the mentioned projects in the cognitive continuum. Next slide, please. And so today I will give you a quick overview on Codeco and then focus more on the topic of the webinar, which relates to the use of AI in Codeco. So Codeco is similarly to other projects in this topic, an orchestration framework. So this means a management framework for containerized applications across edge and cloud. Was edge means the far edge. And so the vision is that across cloud edge IoT, we have applications being deployed based on architectures of, so microservice architecture, so containerized components of applications. And currently they can be deployed, as we know, not just on the cloud, but actually with some freedom. Normally, they are deployed across near edge to cloud, but more and more, as we all know, the applications are being deployed, or parts of the applications are being deployed closer to the data sources. And so the vision that Codeco has is that these environments are becoming more complex, large scale, and mobile. And that implies that we need more flexible orchestration tools. Next slide, please. Next slide. Thank you. So in terms of Codeco, so then what are we exactly building? We are building an open source framework. So you have the link for the existing code there. Codeco right now has 14 months of life, I believe. And in June, we will release the first open source framework complete. So right now, what you have is components. I will show you in the next slide. But there are other things that we are doing similarly to the other projects. So we are building 6 use cases that use Codeco to manage different types of applications. So this is not management of AI, but actually using AI to orchestrate IoT applications across the far edge to cloud on different environments, for instance, digital twinning or manufacturing, so AGV fleets. So that's the main goal. And of course, we have other assets, as you can see on this slide. Next slide, please. And so what exactly does this framework has? So on the left-hand side, I hope you can see the components of Codeco. So you see the interface to the user, we call it ACM. So in fact, this is, so one of the things I did not mention is that as orchestration tool, Codeco is a framework that is pluggable to Kubernetes. So that's our decision to implement in an agile way an approach that would rely on AI and be flexible enough to do this deployment. And so this means that each of the boxes that you see on the left-hand side is actually a component. On the right-hand side, you have the names. And these components, they do different things. So ACM is basically, as I said, the control plane, so the management plane, and is actually based on an existing open source Red Hat tool, OCM. And then we have a new scheduler based on this seamless workload migration. So in other words, other components of Codeco can be used with a Kubernetes scheduler, but we also have a more interesting scheduler that uses a new approach, who uses a graph-based approach to do the deployment of the applications, not a filter and score approach as Kubernetes does. And we have NetMA, which is, let's say, a component that brings network awareness to the orchestration, which is something that we don't have. So the orchestration that we have today in terms of application deployment relates with computational resources, so node resources. And so NetMA integrates network awareness. What is the status of the infrastructure? How are the nodes connected, etc. And the AI part resides, so the core, let's say the orchestrator, the brain, is actually PDLC. So it's another component that can be used alone or together with the other components of Codeco. So where do we use AI then and why? We use AI to provide estimates on the, let's say, infrastructure. So this so-called edge to cloud IoT infrastructure relates to us. The vision is that it's not just a set of nodes, a graph, it's actually the nodes, the links between the nodes, and also the data workflow. So one component that you see also there is the metadata manager, which creates an observation of how the data is flowing across the cloud edge IoT infrastructure. So I said infrastructure to us is network data compute. And so that's also a new approach that Codeco brings. And we use AI not to do the deployment. So in fact, the decision to do a deployment of the application is actually on our new scheduler, so this SWM. But actually AI passes an estimation to SWM, and SWM takes that into consideration when doing the application deployment. So why do we use that? Because, for instance, if we think about, let's say, a cloud edge IoT environment, which is mobile and where nodes are mobile, it may happen that SWM, so a scheduler, decides to do an application right now, an application deployment, and in a couple of seconds or minutes, there is a node that moves. And so this selection, this instantaneous selection was not necessarily the best, taking into consideration history of the system or of the infrastructure. And so that's where AI enters. So that's one of the parts that we use AI. And another part is, of course, to do an estimation of the use of the resources. So this means, for instance, at a node level, this means CPU, memory, so what is the status? At a network level, this means, for instance, bandwidth, energy consumption, so transmission, how much energy are we using? And at the data level, this means data observability. For instance, what is the freshness of the data? Is the database of an application growing too much and we need to do something about it? So in terms of which AI do we use right now, so Codeco is the first phase of Codeco, so first 18 months is deployed to build all these components and to validate and test them in a single cluster infrastructure, which is something a little bit easier. So the next phase, which starts in July, relates with federated clusters. And we use AI, so in this orchestration, okay, and right now for the single cluster, we are studying approaches that can be extended towards decentralization. But of course, in a cluster, we don't necessarily need decentralization. We can apply federated learning. So what we are using right now to do this estimation and to pass it to the scheduler is reinforced learning, okay? And then with a specific reward function based on outputs that the scheduler gives. And for instance, let's say for the analysis and estimate of usage, we use GNNs. And for the next phase, for decentralization, we are analyzing swarm learning. So that's one of so for the federated cluster operation, we expect to use Marl or swarm learning. Next slide, please. So this is my last slide. So here you have a link for the current architectural status. If you want to check, there is also code that you can download for this part of PDLC, which you can test. How do we use, so the models, the training, etc. And basically you have a summary also on why we use AI. So I explained what we use and here why we use AI. Thank you.
Thank you very much, Ruta. That was a very interesting presentation and very rich in the amount of AI that you're using across the whole architecture. Are there any questions from any other members, or shall we reserve the questions to after all the presentations? Yeah, shall we do that? Okay, then we go to the next project, Edgeless. Please, Claudio Cicconetti, would you please present your project?
Yes, with pleasure. I thank the organizer for the kind invitation. I have the honor of being the technical manager of the project. Next slide, please. So the ambition of our project is to enable low-code development of application, which will be then deployed and managed efficiently and in a secure manner in the edge cloud continuum. So yeah, at this high level, I guess there are many things in common with all the projects in which will also with Codeco and the other projects which we'll present later. So let me explain a bit what we mean in particular. So by low code, we are focusing on the stateful function as a service concept. So in edgeless, as the name sort of implies, we want to adopt the good things about serverless computing, which are mainly the flexibility in the orchestration and runtime scheduling of resources, the fine-grained granularity with which you can load balance and also bill about the use of the resources, etc. But we want to make this stateful, because as it is well known, most serverless computing platforms are stateless the applications, because this is so much easier. In our case, we want to add the state because we need the state for the AI applications, which makes the overall approach AI friendly, as will be demonstrated in our use cases. So the applications in our case are mostly AI tasks. For the deployment, we target at having automated processes for continuous integration and continuous development. Efficient here means, again, to use AI in this case for decision making and for anomaly detection, which is something which AI appears to be good at. Secure, with secure, we want to exploit the technology that enables applications to run in a trustful environment, such as using trusted execution environments or trusted platform modules, which are available not only in the cloud, but also in our edge nodes, where the edge for us, like for Codeco, is the far edge. So we are targeting resource constrained devices, which are unreliable, which can be mobile, which can have very limited resources, and that might have specialized hardware. Well, specialized in this case, you might guess, is for the execution of AI tasks again. Next slide, please. This is the big picture of edgeless at the moment. I don't think it's a good idea to go into the tiny details of this, but I would like to give you a high overview about the journey that we promise to give the users of edgeless. So this all starts with the application developer on the top left part, which has an application to deploy, and they can compose this application as a workflow of stateful Lambda functions that interact with one another. This is also called, I think, in the literature, micro agents approach, or micro actor approach, also in some scientific papers. So this workflow, which also has annotations regarding the service level objectives that the application developer wants, and the characteristics of the load that they expect, is given to a controller, which we call epsilon controller, which will then take it to the resources via what we call edges epsilon orchestrators. So there is one controller for the whole cluster of resources that are managed by a single administrative entities, but this cluster can be split in multiple local domains, where one local domain can be, for instance, the cloud on the bottom right, or an edge computing cluster of nodes in the bottom left part with constrained devices. And it is possible that because of to have the optimal use of resources, some of the functions that are requested by the same user go on one orchestration domain, for instance, Lambda 1 and Lambda 2 in the picture, while Lambda 3 is executed on a cloud node for some reason, which is selected at runtime by a joint operation at the epsilon controller and the epsilon orchestrators. And we also foresee the existence of multiple clusters where you have a multi-provider system, which will have to happen via the definition of suitable multi-provider contracts on the top of the picture. To enable the continuous integration, continuous development pipeline, we have on the right the funcdev, which is the function developer in our terminology, which creates those functions and pushes the code to a code repository, which is automatically built into binaries that can be executed on the multiple types of hardware our cluster consists of, into a function repository, which is then used by the different elements of the system, so that it is possible to deploy, if this makes sense at all, one function on a Raspberry Pi device, another and on an NVIDIA embedded device, or in a container inside a cloud node in the public cloud. Where is the AI? The AI is in two places. So one place is in the optimized execution of the system, so in the SLA management, and in the runtime orchestration that is done by the Epsilon orchestrators. And we want to use AI in order to capture all those dynamics that are difficult to guess if you want to. Yes, I'll wrap up soon. If you want to do a good job in the orchestration, and we have AI in at the application level. So the AI runs inside these Lambda functions, which can be AI tasks. Next slide, please. We have three use cases. I didn't bring many details for that, but I just mentioned them briefly. We have an advanced mastery surveillance, where the AI tasks consist mostly in the detection of object and of context situations based on computer vision. We have an Internet of Robotic Things, where the AI tasks are used both for acquiring the context about the environment of a movable robot, and for the acquisition of natural language processing if we have the human in the loop. And the healthcare assistance use case, where the AI consists of human activity recognition and similar tasks that might happen within a customer house. And that's it.
Thank you very much, Claudio. Very interesting. Another very good example of using AI across the whole edge to cloud continuum. Let's move on to the ENACT project. Alexandros.
Hello, I'm Alexandros Nizamis from Center of Research and Technology, Hellas, that coordinates ENACT project. ENACT project is focusing on adaptive scheduling and deployment of data-intensive workloads and targeting energy efficient from edge to cloud. Please move to the next slide. The project has started this year, is under the topic related to cognitive compute continuum. So we are now in the month 4 of the project. We have 16 partners coming from 9 countries. We have some leading European institutes. We have 2 large companies such as Siemens and Fujitsu, and also 9 European SMEs. Our pilots here are based on media distribution and the improvement of user experience based on cloud edge technologies. So Moog Technologies company and SPTD provide this type of pilots here. And we have also Fujitsu, that is our 3rd pilot, and we have a digital twin related to mobility for the Tokyo city, and we're going to apply also our cloud edge technology there as well. Move to next, please. So this is our main concept and our main objective, let's say. First of all, is to develop technologies that will enable us to realize a cognitive compute continuum that can address the needs for optimal deployment of the resources, to provide dynamic scaling, elasticity, portability for this kind of hyper-distributed applications, as I described so far. So what we are aiming to deliver here is to provide various tools that will enable us to connect and discover the various distributed resources that we will have in the pilot cases that I have just described. Our core AI part is the AI-powered orchestrator that will combine different kinds of technologies, as I will explain in a minute. And also we are aiming to provide an application programming model and an associated software development kit for this model. The idea is to have some kind of portable applications that can be configurable in a different way if we're going to deploy them on cloud or if we're going to deploy them on edge. In our main concept here, we have a graph-based approach. We're going to create a graph of resources. Then the idea is to try to get this information of this graph and instantiate some kind of GNN models and try to combine them with reinforcement learning agents. So the GNN models and the created graph will provide us a kind of the topology. We will have some kind of AI forecasting as well that will let us know for some cases and simulations that we can get based on the current state of the compute continuum and the deployment that we are planning. And after that, we are going to combine them with RL that we will try to use this kind of information as the goals that they will try to optimize. So based on the graph that has been created and this AI forecasting and prediction, we will try to run this RL agent to optimize this kind of goals. So this is our main concept regarding the AI. So we have a kind of combination of technologies near to what we see in the first presentation from Ruth and Codeco, I think. So it will be nice to see how we can do some stuff in parallel, check any kind of synergies and so on. And I think that's it for me. As I said, we are in the beginning of the project, so this is the high-level information for us now, and we are on the design phase of the project. And
Okay, thank you.
And you can see more info from us in the next slide that we have our website, social media, and so on.
Yep.
So thank you.
Thank you very much, Alexandros. We will talk later more also about some of the challenges in your project. Let's move on to Intent project. Hui Song, would you please present?
Yes, my pleasure. Thanks a lot for inviting us to this event. It's very exciting to see many interesting things happening in other projects. I can already see a lot of interesting collaborations that could happen in the coming years. So I'm also looking forward to this kind of events later on to have more collaboration with each other. So I'd like to introduce briefly our project called Intent. The full name is Intent-Based Data Operation in the Cognitive Computing Continuum. You can see the 16 partners in the below. We have large companies and universities from 9 different European countries, plus 3 partners from the South Korea. Please, next slide. So first, our project is kind of relatively young. We start together with Enact, I think, so only a few months old now. Also, interestingly, that we start in a slightly different time. Before we, so it's a time that the AI has been developing very fast, and we start to see AI behave more like a human in many different areas, like they can talk, they can write poems, they can draw, they can even sing. So we had the similar question, is it possible that the cognitive cloud could be a bit more advanced with similar kind of intelligence like a human? And we specialize this requirement into 3 directions that are relevant in this context of cognitive cloud. So we believe first that the cognitive cloud should be able to adapt like a human. They should continuously learn how to handle the different situations and different type of resources without having the pre-defined knowledge or experience about what the resources are and what the data are like. And then since a continuum is a composition of many distributed resources, then the decision, whatever decision that was made by AI should be somehow strategic, even if maybe each special part of AI agent will only have some localized knowledge. And last but not the least, we want AI to be able to talk to the human, to understand what the human stakeholders really want about the continuum and about the data pipelines running in the continuum. And at the same time, they should be able to explain to the users what and why and how they make certain decisions in order to create the trust between the AI and the human. So we want to explore these technologies to eventually achieve what we call the intent-based data operation. And we want to apply this in 5 use cases, which I'm sorry that I didn't have space to put them into the slide. So we have use case on the application side to look at the green video distribution in the internet, and also on the machine data analysis. We have also use case on the infrastructure side, trying to see how to use the 5G infrastructure as a data processing platform, and also how to support the platform beneath the data space. And finally, we have experimental use case looking at the robotics, how the data flow through many distributed robots. I also have a slide trying to explain the technology. If you could turn to the next one. I think this would also answer the questions about what types of AI we plan to use. So if you look at the very bottom of the continuum, so we consider a continuum as a composition of many resource domains from the public cloud all the way to the edge devices. And we have the data pipelines flowing through these resources. And please, it's not next slide, but there's some animation. If you click, I should probably see something more popping up. Yes. So the first step would be to use some agents to manage the data pipelines and the resources within the resource domains. This is a typical problem for data orchestration and data storage management, network management, for example. And we have partners who have already looking at using AI to solve these problems in a more intelligent way. And we further challenge them to do this in a more continuous way, to be able to continually learning what resources are available in the system and how to manage the resources in a more efficient way. So here is mainly the traditional machine learning or deep learning techniques, but with more reinforcement and a continual learning flavor there. And on top of this, if you could click again, we consider that these agents need to collaborate or need to be coordinated. And here, this is a problem, open problem of decentralized intelligence. We're trying to learn from theory explaining how our brain works in a decentralized way. There's a theory called the global workspace theory, which coordinate multiple agents with local knowledges and try to make them to work in a strategic way. And we do it in a similar way, and with the support of how to measure the end-to-end security and the trustworthiness of data pipelines through multiple resources. And finally, the last pillar of the work, yes, it should be the next click. Now we're talking about how to make all these agents and the coordinators to talk to the human stakeholders. Here we will exploit the generative AI, especially the large language model, to interpret the human intents into low-level commands in order to talk to the agents, and on the way back to explain how these agents make certain decisions. And these will put together into a chatbot based on the knowledge graph of all the continuum and the user preferences. So I hope this could briefly explain what AI we would like to try in this project. And I'm ready for the further discussion in the next sessions.
Thank you very much. Thank you, Mr. Song. We move on to the next project, CogNet, and Georgios Spanos will present it.
Hello, everyone. I am Georgios Spanos from Center for Research and Technology, Hellas. CERT is coordinating the CogNets, continuums of game nets, short intelligence as information processing. This is a project that has 36 months duration, but has not officially started yet. We are in the GA preparation. Please go to the next slide. Okay, Some introduction to the Cognates project. The ambition of Cognates is to develop a middleware framework that is able to empower IoT to cloud devices in order to organizing autonomously with dynamic IoT to cloud swarm continuums for optimal data processing and seamless service provisioning, following a specific approach, which is the on-demand opportunistic approach based on asymmetric multiplayer competitive games. Asymmetric multiplayer competitive games is a core proposal of Cognates. Essentially is an extension of the swarm intelligence in order to contain the self-organization in terms of pricing, bidding, and auctioning. We can have the chance to discuss a little bit more after that in our session about AI. Please click in order to. Yes, I think okay. Yes. In my presentation, it was a little bit different, but okay.
No problem.
Of course. Our consortium comprises 5 big industries, 6 innovative SMEs, 5 research and technology organizations. One of these organizations is ours. And finally, 5 universities. And of course, in the map, we can see the different countries that compose this consortium. So, what are the main objectives of Cognates? The first one is to build intelligent game agents that can enable self-organization at the edge level. Here we have the devices, using feature-based heterogeneity models and asymmetric competitive games, as I said previously, with this new technology. The second one, of course, is to develop a middleware framework in order to orchestrate dynamic IoT to cloud swarms of autonomous data processing using also analytical model distribution and delocalized federated multi-context. The third objective is related to security, is to build an end-to-end security for addressing specific swarm-centric threats on all levels from IoT to cloud. The fourth objective is about the collaborative federated learning, and also we have here another aspect of AI technology by improving the AI service response locally, while of course exploiting the whole chain edge to cloud to assist in accuracy and using also AI pruning technologies that we can discuss later. The fifth objective is about the testbed deployment that we plan to develop in our project to validate proof of concept of the proposal of the Cognates. And finally, of course, the final objective is about to identify the different European Union social, ethical, legal, and other aspects of the Cognates and ensure its promotion to all the communication channels related to computing continuum, cognitive cloud, etc. And if you click one more, yes. Here in this figure, we can see first of all the three different use cases that we will pilot the Cognates project. The first one is about the manufacturing and the connected industries. The second one is about the automation and the the Internet of Vehicles, the connected vehicles, and the third one is about health and the connected healthcare organization. We can see in this figure the three different aspects of computing, energy, and security, and the main concept of these game agents that give the opportunity to the devices to self-organize and also including these three main properties of pricing, bidding, and auctioning. Okay. of course, this is the main presentation from me. As I said previously, the project has not officially started, of course. All this information comes from the proposal. We don't have until now our kickoff meeting.
Georgios,
yes,
may
of
I
course.
ask? May I ask a question? So the
Yes.
swarm, of course, is also each agent. It creates some swarm is also some intelligence, swarm intelligence.
Of course.
But
Yeah.
around that swarm intelligence, are you using any other form of AI or ML to feed the swarm, or to control the swarm, or to monitor the swarm?
Yes, in order to monitor the swarm, the main AI technology that we will use, because the project has not started, is based on asymmetric multiplayer competitive games. So the orchestration of the swarm intelligence will be enhanced by this AI technique of asymmetric multiplayer competitive games.
Okay. Okay.
Okay.
Interesting.
But of course, I can elaborate more later in the open discussion about the technologies.
Yeah, perfect. Thank you very much. Then we move on from.
And these are these are our contact details. I am Georgios Panos, and the project coordinator is Konstantinos Votis, and our emails can be shown here. Thank you.
Thank you, Georgios. Thank you very much for the interesting presentation. So we go from Cognit to. I have a different slide in the listing. I have a different one. But okay, we go to WAMI, to Marco Mancini.
No, this is Cognit. It's the point that I sent you a slide also about myself.
For Cognit.
Yeah, this it's for Cognit is the project, right? I sent you just a slide about myself, but yeah.
Okay.
I am from Open Nebula, and Open Nebula is the coordinator of you can go to on the second slide. It's the coordinator of the Cognit project, not Cognit with the I. That has been funded now by the European Commission under the topic of Cognitive Cloud. So the project started in 1st January of 2023 and is finishing in by the end of the 2025 year. So it's a 36 months project. So Open Nebula is the coordinator, and we are the consortium is 10 partners. So with other 9 partners, we are implementing and executing this project. So we are almost close to the let's say mid-term, the interim period in a few months. And so we already started about the project and designing this framework for the Cloud Agent Coder. You can go on the second slide where I will talk about what is the aim of the project and where we use AI mainly, because this event is to talk about how AI can be used for cloud and which technologies can help in improving, for example, the cognitive cloud computing. So the main aim of Cognit is to look at this cloud edge continuum. So we go from, considering all the resources that we can have going from the edge or the far edge, very close to where we have IoT edge devices that needs to execute functions, to execute workloads. So the Cognit is based on the concept of code offloading using a serverless paradigm. So the main aim is that from the application perspective, user perspective, we would like to use this serverless paradigm where the application doesn't have to take into consideration all the different ways to manage resources. Now, if we look just at one cloud provider, AWS or Google Cloud or one public cloud provider, they provide one way, for example, to run function as a service, right? They provide serverless framework, and they have their own API, their own framework, and so on. If we look at multiple clouds or even heterogeneous in the resources that like edge providers or telco providers, public providers, on-premise or data centers and so on, private clouds. Clearly, this make things even more complex. If I have to manage all the different layers that go from the far edge until the public cloud. Also, because I have to take into account that an application or the function can have different requirements according to what I need to do. So for example, for some function, I have very low latency requirements. So the best would be to execute the function where the data, for example, is generated, should be executed. Maybe there are some other tasks that maybe they do at aggregated levels of information that I can push to the cloud center. So the idea, first of all, is to build a framework that manages all the complexity that is behind the cloud edge continuum when we are considering heterogeneous resources. So, and there are even no interoperability issues, there are security issues and so on. So this is the first thing, is that we need to provide a framework that allow us to exploit all the resources that are along the cloud edge continuum. And the second point is how we can improve the management of these resources by using AI. So the core of the Cognate project is the brain of the framework is AI-enabled orchestrators that takes into account not only the requirements that comes from the different, let's say, edge devices or application at the edge, so in order to execute this function, but it takes into account all the complexity that comes from the different resources, okay? So the main point is that we are working on having a monitoring system that can provide all the metrics, for example, related to infrastructure, to applications, metrics that we store in a monitoring system, and these metrics can be used by using AI approach in order, for example, to characterize the workload and also to predict, for example, if we have time series, to predict future workloads, okay? So the AI is used both for workload characterization, so we need to understand which kind of dimension in the cloud edge continuum is going to use. Now that goes from CPU to networks to latency and so on. In prediction, also trying to predict what would be the future workload. And so we can use approach that, for example, analyze time series mainly. Okay. So I will try to be, because maybe we are a bit late, I don't know, so let me just go very briefly about, so what we are going to provide is this function as a service serverless paradigm that can exploit all the resources along the cloud edge continuum. We are going to use also open source solution, like we provide this Open Nebula, some SUSE ecosystem tools and so on. And the other point is that we consider also security, energy efficiency heuristics, because we consider also the fact that we would like to optimize this workload also according to optimize also, for example, energy consumption, that is really important in order to have sustainability for this kind of thing. I will just very briefly say that we have 4 use cases that are about smart cities. This is led by the Assisa partners, that they are building this distributed intelligence system for transportation, where we are going to tackle the problem of prioritization within a city, like for example, emergency transportation or public transportation, especially in areas that are densely populated. We need to define priorities in order to allow transportation. The second one is about wildfire. The partner Nature 4.0 has built some IoT devices for wildfire detection. So we are going also here to use this framework in order to offload using some ML AI techniques to detect, for example, fire coming from cameras. The third one is about the energy. So here the 2 partners are Phoenix and Attende, and they are building this kind of distributed energy smart meters where they
Yeah.
can run application at the edge and offloading, for example, also this in some decision-making algorithm based on MI and ML and AI. The last one is about cybersecurity, because in the cloud edge continuum, one of the issues are that we have more points when there can be attacks, especially at the edge. If we consider application when there are multiple connected IoT devices like vehicles, here CETIC and SUSE are collaborating on this project where we analyze, for example, anomaly detection using ML and federated ML AI. So we have ML AI both within the framework for orchestration of resources and managing the workloads, according to objectives, and also in the use cases. Okay.
Good. Thank you, Marco. I think, if you don't mind,
Sure.
because I think I also want to give a few more minutes to Cloudskin as well, because then we have all the projects described. We have a wide view.
Sure.
We eat a little bit into the next session, but then at least everybody had time to present their interesting project. Yeah. So thank you very much, Marco. We go to Cloudskin. Mark Sanchez, please.
Good morning. So thank you for inviting us to participate in this webinar. So yeah, I mean, our project started last year, so it's like more or less in the half of the project. In a few months, we will have the mid-review project. So essentially, our project comprises like 12 partners. There are from people that is specialized from managing resource provisioning using AI. It could be, for instance, Barcelona Supercomputing Center, who will manage the AI part. We have also people that is more specialized in virtualization. And there are also, we have people that works a lot, let's say, in hardware acceleration. So we have, let's say, a project that tackles the whole spectrum, so, from the orchestration side up to the hardware resources. So the thing in our project essentially is that we have like several problems that are available. One of those that is very important is about silos, because most of the projects, what is happening is that they are stitched to one specific technology, as I said in the beginning. So there are people that is basically working with containers, others are working with serverless functions, and so on and so forth. So our model is like to try to provide a common layer that can be executable across the whole cloud continuum. So we are using something that is called WebAssembly containers that are extremely lightweight and allow us to run computations across the whole spectrum. Please, could next slide, because there is a few remaining time. So our goal, as the rest of the projects in this call, is to develop a cognitive cloud that can exploit essentially the heterogeneous resources that we have available. So in our case, yeah, you can click everything, so it will be the complete slide because we don't have much time to discuss it. So our idea is like first to develop a general orchestrator. That orchestrator essentially is like a learning plane that is built using input from other orchestrators. In our case, we are not stitched to Kubernetes, for instance. We are like providing an APIs that can use to connect to different kinds of orchestration. The reason is quite simple, because Kubernetes could be very well for, let's say, fat edge servers, but could be not efficient for let's say, mobility use cases. So in the end, we're creating, let's say, an orchestrator using AI that is able to interact with the rest of the orchestrators that are below the layers. So that orchestrator has a pool of models, and this pool of models are applied depending on a specific use case. The main goal, because here is more about AI, the main goal of the orchestrator and at the level is for decision making. That could be task placement, to decide where to put a given task in a specific place. But also we have AI applied at the application level that is quite similar to another project that was presented before. So we use, for instance, we have a use case that is based on metabolomics, and this use case uses neural networks to identify or classify metabolites. So we are applying AI to orchestrate, again, AI inference to make it quite effective. One example to conclude, because I don't want to extend a lot, here you have like a circuit, and this illustrates a lot what is our focus, because in that scenario, we have like vehicles that go across a circuit, and we have like cameras that are connected using 5G technology. So the thing is that these resources are quite stringent, and we cannot just fully occupy with our computations all the available resources in the circuit, because it could be other companies that at the same time are using the same resources. It could be what's called multi-tenancy. So our focus here is that move the analytics application across the circuit following the car. So with that scenario, we have to predict the direction of the car to move at the right time the analytics applications to another server. So in this case, the AI is like predicting the time that the analytics application should migrate to another server. And this is done essentially to get input. This data is pre-processed at the edge, servers that are using 5G, and then they are moved to a central cloud for further processing. So this is like a clear example of what it's Cloud Edge Continuum. So we are managing the whole spectrum. So okay, so you have much more questions. You have, and the slide is not essentially what I mean, it's so big, but I think they can get my email if you want to ask something.
Thank you very much. Thank you all for your presentations of your projects. They're all very interesting, and also the spectrum is very wide.